Good morning, everybody. Thank you for joining us today. Today, we're going to give you a brief discussion into collaborative robots, and then we will dive right into some machine tending applications. Tyler Mays, the channel sales manager in the Eastern USA for Robotiq, will explain the product and its capabilities and how automating with their solution can help you. Jason Horn, a sales engineer with Ralph W. Earl, along with Mark, an integration coach with Robotiq, are also on the call. And Mark will be giving us a live demonstration of the product throughout. We are going to be recording the webinar today, so I'm going to have all of the attendees muted during the webinar. We do encourage you to submit any questions you may have throughout the presentation using the questions panel. And if the timing is right, we'll interact and answer them as they're submitted. Otherwise, we'll answer all your questions at the end of the presentation. With that said, I'm going to hand this over to Tyler so we can get started.
All right, thank you very much, Steph. And good morning, everybody. And welcome to the special presentation of the Robotiq Machine Tending solution presented by Robotiq and Ralph W. Earl. So as Steph mentioned, my name is Tyler Mays, and I'm the channel sales manager for the Eastern USA at Robotiq. And I'll be covering a brief introduction to Robotiq, who we are and what we do. And then we'll talk a little bit about why machine tending, some examples and case studies throughout the history of both Robotiq and customers automating machine tending with robots. We're also joined today by Marc Antoine, who is an integration coach at Robotiq, and he will be performing a virtual remote demo in real time. So you guys are going to see how to program this thing on a robot and also see in real time what some of our software functions can do to help you increase productivity and start production faster by automating your CNC machine tending with a universal robot. So Jason, if you wouldn't mind both introducing yourself and Ralph W. Earl.
Yeah, thanks, Tyler. Appreciate it. Thank you all for attending today. Ralph W. Earl, we're a distributor in New York State for automation and motion control products, systems, and within the last 4 years, we've grown into this collaborative robot field, supporting installations around New York. We have represented Robotiq and Universal Robots for 4 years now, helping Western New York manufacturers throughout the state with simple automation to support, and New York State, excuse me, to support simple automation into their current existing processes to help efficiency and solve some of those needs. Specific to machine tool in the CNC world, we've installed and helped with integration into mill application, lathes, Swiss machines, deburr applications, some gauging, and also part washing. And like I mentioned, anything from supplying and supporting the components for those pieces of automation, all the way up to helping with the full integration. So we look forward to hearing your questions. And Tyler, it's back to you.
All right, thank you, Jason. And like Jason said, whether you already are using universal robots and automation in your facility, or you're here joining us today because you're considering adding a robot to your production, we have the tools and resources to help you out no matter where you're at. So don't worry about that side of things. All right, so who is Robotiq? So Robotiq is a company founded back in 2008 with a company mission of freeing human hands from repetitive tasks. And that has materialized itself in different ways, both through our hardware and software products through the years. But as we stand today, we have freed thousands of human hands for more value-added tasks on the production floor. Our company is based in Quebec City, Canada, and all of our products are made at our headquarters there in Canada. As we stand today, we are about 150 employees, and we have our office in Quebec, Lyon, France, and then we're also in the process of opening up in the Asia Pacific region as well. So Robotiq, we also use a foundation for deploying automation systems quickly and efficiently called lean robotics. And one of the key learnings from lean robotics that we know, again, from these thousands of deployments that we've done, is that the challenge is not the robot. Robots are very good at what they do. They're reliable, they're consistent, they're accurate and repeatable, and they're going to do exactly what you tell them. But the truth is about a robotic deployment is that the cobot cell itself is where the challenge truly lies. So in this image here, you can see everything around the cobot that needs to be considered, including interfacing with a machine, tooling, sensors, part feeding, programming, training, and upgrades. And basically, I don't say all these things to try and overwhelm you and say that a cobot deployment is going to be confusing. What I mean to say is that you want to lean on Robotiq, Ralph W. Earl, and Universal Robots to tap into our automation expertise and help you determine what's going to be best for your production. So a little bit more information about Robotiq is that we're probably best known for our plug and play components for Universal Robots and other robot solutions. That comes in the form of what we call adaptive grippers, which is what you see on the bottom left of the screen. That is our 2-finger 85 gripper. And so we still do a lot of that business today. And in fact, it's kind of our bread and butter. But as time has gone on, we've realized that we can solve more of the application by combining our plug and play components into kits specific to certain applications. So outside of CNC machine tending, we also have kits for surface finishing, sanding, and other such applications. So in the CNC machine tending kit, which is obviously what we're going to be diving into more today, that falls into that application kit space, and that's what you see in the middle of the screen. And then most recently, Robotiq has also gotten into the application solution space. So the image you see on the right of the screen is our palletizing solution, which if you do have a palletizing application, I would encourage you to get in touch with Ralph W. Earl and Robotiq to talk about that, but that's obviously not the content of today's webinar. So the first question we want to address is why a CNC machine tending kit? So a little bit more information about CNC machine tending through the years. CNC machine tending is one of, if not the best selling application for robots. But if you look at the image on the right here, that's actually from about 10 to 15 years ago at this point. And that solution is using an industrial robot and Robotiq's 3-finger gripper. What we found was that industrial robots aren't well suited for machine tending because they're very complex to program. They require a lot of safety to be implemented in the cell as well. And that means that it's not a flexible solution that could be moved out of the way in case you want to manually run a process or a different part. Basically, once that industrial automation has been put in place, it's going to be dedicated to do that task until it's decommissioned. With the introduction of collaborative robots, that really has changed because cobots can work side by side with humans without the need for hard guarding or other safety equipment. We do always recommend that a safety risk assessment is performed when you implement a new cobot, but in a lot of cases, you can use the universal robot without the need for external guarding. So another part about our experience in CNC machine tending through the years is that we've gained a tremendous amount of knowledge from our field experience. We've deployed thousands of robots and thousands of grippers as well for machine tending applications, and that has given us a tremendous amount of field experience to really tailor our products to the machine tending environment. And we'll dig in a little bit about what that means. But it also gives us the experience to know what makes a good CNC machine tending application, how you can have flexibility in both the hardware and software that you're utilizing on your production floor, and again, how you can start production faster and both reduce operating costs by having a robot tend a machine instead of an operator, add consistency to your cycle rate, reduce the cost to manufacture each part by using a robot, and more. We also have gotten a tremendous amount of customer feedback because we do work close with our customers and partners to make sure that our solutions are the best they can be. So this sign here, I believe it's something that was pulled off of Google, but I believe the area code is actually in the New York State area. But the messaging behind it is that machinists are wanted, and it's not just local to New York. It's across the country, and truthfully across the world as well. Skilled CNC machinists are hard to come by, and they're also quite expensive. We'll dig into that a little bit as well. And so what we know from that is that we don't want these machinists to be tied up, standing there loading and unloading machines. We want them to be doing the things that they find fulfilling and engaging, which is setting up new tooling, programming, etc. And we can leave those low-value tasks like machine tending to a robot. So a little bit more information to give you a frame of reference about the costs for a CNC machinist across the country. Outside of New York State, in Minneapolis, Minnesota, the average salary for a CNC machinist is $73,000. In Los Angeles, California, it's up close to $90,000. And in Fort Worth, Texas, it's $75,000. So I'm not sure how exactly that compares to what your costs are to hire a CNC machinist, but the messaging really stays the same throughout, that those CNC machinists are very valuable. We want to make sure that we're engaging them in the work that they do and not leaving them to these boring, dirty, dull, and dangerous repetitive tasks that are really better suited for a cobot. So the other message that we like to convey with our machine tending applications is that we want to keep the spindle running. When the spindles are running, the machines are generating revenue, and we know that downtime is the enemy of every CNC shop. So let's dig in a little bit more to Robotiq's CNC Machine Tending Kit, and we'll identify the ways that we help you keep those spindles running and eliminate downtime. So first and foremost, as I mentioned with that industrial robot, machine tending tends to be problematic for a number of different reasons. There's a lack of reliability from the robot if you're moving it from place to place. Fast changeover is not necessarily possible, but it can be by using the right components in your solution. Does the robot and the grippers have a high capacity to handle a wide range of parts is a question you always need to ask. And the final thing to figure out is, where's the knowledge gap? Do we know how to if we know how to program a CNC machine, but we don't know how to program a robot, that leaves us a knowledge gap that both Ralph W. Earl, Robotiq, and Universal Robots are able to help you fill with a number of free and easy to use resources. So I'll start with a brief video here, and please don't worry that the audio is not going to come through. But I want to give you a video reference to see just how a robot does machine tending. So we see here that flexibility that you're able to move the robot from one machine to another, depending on what different jobs you're running on your shop floor. We have flexible software and tools, like our visual offset tag that you see here on the screen right now, that enable the robot to move from place to place and take one picture or do one touch off to register the robot to the machine that it's working on or whatever other work surface. All of our software lives on the robot's teach pendant, and it's integrated through what is called a UR cap, which is kind of like an app on a phone. So controlling the grippers, controlling the wrist camera, and the Force Copilot software is all intuitive and easy to use on the robot's teach pendant. And then finally, the products are meant for that harsh industrial environment. So we'll dig into that here a little bit as well. So just jumping into the CNC machine tending kit itself to give you a frame of reference for what's included. On the software side of things, inside of the wrist of an E-Series universal robot, there's a built-in force torque sensor. Now that sensor itself is actually Robotiq's technology, which is now integrated on every single E-Series robot. And so What we have is our Machine Tending Copilot software, which adds a lot of different features and functionalities and takes programming from being 100 lines of code down to a simple interface where you just say, hey, I want this to do a spiral insertion to load a part into a chuck, or I want to make sure my part is fully nested in the vise within the CNC machine. Um, you'll be able to see that in a lot more detail during Marc Antoine's demo, so I'll kind of breeze through it for now. Next, right after the robot's tool flange, you have the option to either use Robotiq's wrist camera or not. It depends on your particular application. But we do find that about half of our CNC machine tending kits are deployed with a wrist camera because it does add a tremendous amount of flexibility and versatility to your robot. Our wrist camera is seamlessly integrated as the coupling between the tool flange and the grippers, and it has its own LED lights, etc., which enables you to take a picture and find parts on a work surface, and then automatically our software guides the robot to go ahead and pick those parts and then take the next step of the operation, which is probably loading that part into the machine. On top of that, with the camera, we can ignore parts that we're not looking for if those happen to be in the vicinity. We can do barcode scanning and run a certain program based on the barcode we scan. We can also use what we call visual offset, which is a routine where the robot's camera scans a tag, and based on that picture, it's able to reorient the entire robot program based on how the robot is positioned relative to that tag. So when you're moving this robot from machine to machine and using that type of flexibility in your shop, you don't want to be spending time reprogramming the robot's waypoint positions every single time it's moved. You can use that wrist camera to make that very simple and straightforward and not have to be a headache for you as you either take on a new application or just deploy it in a different space. Next, we have the dual hand E grippers. Now, the hand E gripper is currently the best-selling Robotiq two-finger gripper, and the reason is because it's truly a robust solution. It has an IP67 rating, just like the camera, so it's meant for the harsh industrial environment that a CNC machine has. It's able to work in the coolant, and that coolant does not affect the electronics of the gripper. So that's always something that you want to keep in mind and make sure you're using products like the Handy that are meant for that harsh environment. Finally, Handy has flexibility by being able to swap out fingertips. So on the screen here right now, those are our over molded fingertips, which are great for picking metal parts and not marking the surface. But if you're looking to shape those fingertips to be able to engage with your part, you can add customized fingertips. If you need to extend the stroke of the gripper to grab wider parts, we have fingertip extenders to be able to do that. And all of that flexibility and versatility are things that Robotiq and Ralph W. Earl can help you design into your CNC machine tending cell. Now, I'll also pause here for a moment to say that if there are any questions from the attendees, please don't hesitate to put those in the chat. I know we're covering a lot of information here, and we want to get to this remote demo, but if there are any questions in advance that I can answer, please don't hesitate to post those. So talking about the problems that have traditionally plagued CNC machine tending robots and applications, we talked about that lack of reliability. And so what our products do is to really solve that issue. So I just mentioned how the Handy gripper is sealed with that IP67 rating, meaning that it's not going to fail in that harsh industrial environment where many other gripping solutions are not suitable for that type of environment. With our gripper, since it is smart servo technology, we're able to do presence confirmation, meaning that we can measure the part that we have in our grasp. We can confirm that the part we're grabbing is the right measurement. And we also are able to confirm as the robot moves around to say that the object is detected and we haven't somehow dropped a part. You also have the ability to pick and re-grasp a part if needed, to reorient it, etc. We have all that flexibility built in because, again, it's a smart servo gripper where you can control the speed of the fingers opening and closing, the position that they open and close to, and also the excuse me, the force with which they're opening and closing. With the Copilot software and our force control, adding that sense of touch to a cobot, we're able to do insertion. So we'll see that in the remote demo here in a couple minutes. But for this image on the screen, we're able to load this part into the vise, and we confirm that it's fully seated on the bottom and then fully nested into the vise itself before we go ahead and run that CNC program. We also, through our machine tending Copilot software, can do a fine surface. So we can make moves relative to a surface, or we can use that contact offset. That contact offset enables you, for this image in particular, you could do a touch off on portions of the vise and make sure that the vise is in the proper position. And if it's not, there's no need to worry because we can automatically adjust the program by making relative moves, and the gripper will touch the sides of the vise, figure out where it is within the CNC machine, and then go ahead and load the parts appropriately. In terms of the need for fast changeover, again, something that is not offered by a non-cobot solution or an industrial robot. We also, through our camera and through our contact features, there's no more need to have complex and expensive fixtures to have your parts in place. Typically, with automation, one of the most important things you have to worry about is having those parts in a consistent pick position. And honestly, in my experience over the last few years, that is something that had always been a cause for concern is, okay, great, the robot is going to be perfect for loading and unloading the machine, but how do I stage my parts? By using our contact offset features, you don't have to worry about how a tray of parts is positioned. The robot can adjust itself accordingly. With our wrist camera, you can both find parts to be able to go pick and load into the machine, or you can use our visual offset. If you are using a nested tray of parts, all you have to do is put that tray within view of the camera, and then it's going to adjust itself accordingly to pick those parts off that tray. Another thing
Hey,
that
Tyler.
plagues, yes.
Oh, hey, yeah, just wanted to throw in, we had a few questions here. Just wanted to ask you.
All right.
One came in about largest part that the robot gripper can handle. And you're looking, it looks like you're gonna hit that right now, so that'll be a good transition. And then just a question to keep in mind about that was asked regarding how do you present the parts to the robot, and how repeatable does that need to be? So just a couple things there.
Perfect. So in terms of part presentation, that was something we kind of addressed on the last slide. But basically, you have the option to do it in any way you want, whether you want to just spread parts out on a tabletop surface and let the camera find them. If you want to use trays and drawers of parts, there are drawer feeder systems available. And I know, Jason, that's something that you guys have used in some of your deployments
Yeah,
to load up hours and hours worth of parts, and the robot is integrated to work with that. Um, so I would recommend both. We'll cover the part presentation in our remote demo, but I would also encourage you to follow up to this webinar with conversations with the Ralph W. Earl team to match you up with the right product for your needs.
perfect. Thank you.
Absolutely. In terms of the gripper capacity, the grippers themselves each have a 5 kilogram payload capacity, so we're able to pick pretty heavy parts. And in terms of the size, there really is there's not necessarily a limit. And Marc-Antoine, please jump in if you have any input on this as well. But with our gripper, the handy gripper has 50 millimeters of stroke, meaning that you can handle parts within the range of 0 to 50 millimeters, or if you extend the fingers, you can handle 80 to 130 millimeters, 150 to 200 millimeters. It's all easily customizable and easy to swap out to meet your needs.
Yep, and it's a good sum up, Tyler. And this is for the ND gripper, but we have also two other grippers that are not in the machine tending kit per se, but you can have that if you want. So we have the 2F85, which has an 85 millimeter stroke. So same thing here. If you want to extend the gripper, you will still keep that 85 millimeters of stroke. And we also have the 2F140, which is 140 millimeters of stroke.
All right, thank you, Mark. All right, so the final thing that troubles us is bridging that knowledge gap. Again, we know how to operate a CNC machine, but we don't necessarily know how to operate a robot or how to communicate with the robot. And that's where you want to rely on Ralph W. Earl and, again, Robotiq and Universal Robots resources to help you out. So for Robotiq, we have an entire e-learning platform, which I'll actually jump into here in a second. But our e-learning platform has lesson plans dedicated to each of our products and then applications as well. So we can show you how to communicate with a CNC machine, how to design custom fingertips, how to set a tool center point when you're setting up the robot with its end of arm tooling, and more. So if I jump into this link here, this is just elearning.robotiq.com, and I would encourage everyone to go ahead and check this out for yourselves to learn more. Each lesson is broken down into about 5-minute segments, and it's easy to digest and work at your own pace. So if I go into the Cobot applications category, and go to the CNC Machine Tending Kit, we can see that the course itself is broken down into a few different phases. These are actually, I mentioned before, those lean robotics phases. We break a project down into 4 phases: the prepare, design, integrate, and operate. And so our e-learning is set up kind of the same way. So if we want to look at the integration phase, for example, and we go to the course, we can view how do the robot and the hardware communicate. We tell you how to use the different I/O signals in the robot controller. We have videos to guide you, program templates, drawings, etc. All that and more is available for free on our e-learning platform. And if you start here at the prepare phase, if you've never deployed a robot before and you're just trying to figure out how, this prepare phase will take you all the way to being a robot expert.
Good, because that was those are some of the questions we're seeing. Primarily how to connect those two together. How do you set up that process? And a lot of those e-learning modules will help walk you through that. Even communication in a physical interface with the CNC machine.
Exactly. And depending on your machine, they may have an interface available to be kind of plug and play with a universal robot. Again, it all depends on the machine itself. But at the very simplest way to do it is to tie the robot's I/O in with the CNC machine's I/O, and we can use that simple discrete I/O communication so that the robot has its task to load and unload the machine, and then with an I/O signal, we can just trigger the CNC machine to start. Or you could even use the robot. I've seen deployments where the gripper themselves actually goes and touches the button to start the machine. All of that flexibility is at your fingertips, and you're able to customize your deployment depending on what your needs are. So again, just to recap before we jump into the remote demo on the CNC Machine Tending Kit, it comes with the dual handy grippers. So that's going to offer you flexibility to be able to pick a wide variety of parts. And then having 2 grippers is very important for cycle time, where we can have a raw part in one gripper, and you have the ability to pick up a finished part with the other gripper to help improve that cycle time and keep that spindle running, again, generating revenue. If you have multiple vices set up within the CNC machine and you have kind of a progressive machining process, you also want to have those dual grippers to be able to move those parts through that process accordingly. Again, the handy gripper, it comes with a bunch of different fingertips and the fingertip extenders, and then you can also create your own custom fingertips if needed. With that machine tending copilot software, we have most importantly the ability to perform contact offset. The easiest way for me to summarize contact offset in a term that you may all be familiar with, it's kind of like what a CNC machine does with a Renshaw probe to go touch off on a part or on the vise to verify positions. We're doing that same thing on the robot side to have a little bit of redundancy and safety built into the program in case some things have shifted. Your robot's not going to crash just because something has moved slightly. That optional Robotiq camera is also available with the machine tending kit. And again, about half of our kits sold are sold with the camera. So it probably would be a good fit for you as well. But with that camera, you can do not just part detection, but again, with our visual offset tags, you can put that tag on a machine and have the robot scan the tag to know its position and relative to the CNC machine. You could put that tag on a tray of parts. So you don't have to put the tray in a fixed position. You could just put it in front of the robot and it's going to automatically orient itself to that tray. You could put the tag on a vise if you're moving that vise around within the machine. The possibilities are really endless on that side. And then finally, we have our e-learning platform available to help you as a free resource you can access anytime. On top of that, we have the local integration support from Ralph W. Earl, and they also, whether you're deploying this on your own or through an integrator, Ralph W. Earl can help you out with that as well, with some time with you on site, showing you how to program the robot or supporting you through an integration. All right. So I will open it up for questions again before we jump over to the live demo. I see a question here, can the Robotiq grippers be exposed to machine tool coolant? And the answer is yes. Great question. And yes, the handy grippers are designed and built for that environment with their IP67 rating, which is not found on every robot gripper. So it's something to always keep in mind. But yes, our handy grippers are designed to work in that machine the machine coolant environment. The wrist camera and the robot itself are meant to handle that as well. Jason, are there any other questions that I'm missing?
Yeah, I think I've asked the rest during the presentation thus far. I know there's some others trickling in, but yeah, if it's appropriate, I'll ask them during, and then we'll cover them for sure, all of them at the end. But yeah, at this point, I think you've touched on all of them.
All right, perfect. Well, without further ado, I'm going to kick things over to my colleague, Marc-Antoine, so he can perform a remote demo.
That sounds good. Let me share my screen. So let me know if Tyler, it's all good. You can see my screen.
Yep, I can see your screen.
Cool.
And we've got both views of the robot. Everything looks good.
Sounds good. Thank you. So basically a quick setup before we jump into the demo. So what we have here is a live teach pendant of the robot. So basically I've got a robot here at home in my basement, as you can see here in the two pictures. And you're going to be able to see the teach pendant live, and we're going to be able to go through the programming, how to program that. And so for the setup, what we have, so we are simulating. So the first video that Tara showed you, so with the machine tending application, so we're trying to do the same thing here. So the first thing is here we have the tray, which is basically the raw parts. So we've talked about part presentation. So for this one, we have a tray, but the tray here is not fixed on the ground. So we simulate an operator that is placing a tray on the table, and we're going to use the contact offset to locate that tray. For some application, we can have that tray fixed, so the robot always knows its position, but it might be simpler on the robot side, but it can be more complex on the design side. So both are really acceptable. So basically, as I was saying, so we're going to use the contact offset feature. So we use the force sensor to touch the edges of the tray to locate that tray. So we don't use that tag for this one at the moment. And then we're gonna go to the next view here. So with the device, we're simulating a CNC machine, and we have that tag that is right here. So for this one, that vice can be movable. So basically, we're gonna use the camera to take a picture of the tag and then locate that vice, so we can adjust all the waypoints accordingly to that new position. So basically, both features, or contact offset and visual offset, are really similar. So we use the force or the camera to locate the new position, and then all the waypoints will be adjusted automatically.
Hey, Mark.
Yes.
Oh, sorry. I just wanted to throw in a quick question if it's appropriate
Yeah,
due to
sure.
this tag. Oh, yeah. Question came in regarding this tag, and could you actually apply and position a tag on the parts tray as well as the machine to locate both for the same application?
Yes, definitely. So we can create, so basically the way we do that, and I can quickly show you on the teach pendant, I think it's going to be better for understanding.
Okay,
So we can create as many tags as we want. So if we go into the
great.
installation, we have tags in here. And as you can see right now, I've got 3 tags created. So I'm only going to use one for this demo, but we could create more than one tag and then use them as desired in the program.
Perfect. Thank you.
So one way to use that tag on the machine tending. So as I was saying, so for the tray, it's pretty simple. So we place a tray around the table and we go for it. For a for CNC machine, I would say. So if we place a tag on the machine, so you could have, for example, one robot that is tending the parts to 2 or 3 machine, and then you would have an operator move the robot from machine to machine. So that way, instead of bolting down the robot and really have a perfectly fixed position, you can just put it there as precise as humanly possible. And then with the camera, you take a picture, and then all the waypoint will be registered. So these two are really setup steps that will really ease and make the setup quicker, in other words. So the other thing I wanted to mention before showing you the demo, so we've got the machine tending kit. So we've got a machine tending copilot with the sensor embedded in the E-series. We've got the camera in here. I've got the ND gripper on one side. On the other side, I don't have a second ND gripper just because with the COVID situation, we just ran out of the office with the parts that we have in hand. So that's why I've got the 2 F85 grippers for the second gripper. So without further ado, we can press play on the program and you're going to see the robot moving. And afterward, I'm going to be able to show you like how it is in the program per se. So right now, we are going to touch the edges of the tray to locate that tray. So we're going to do 2 touches on one edge. So we're going to get the orientation. I'm going pretty slow and I have a mat just because it was really slippy on my floor. So it's just helping me right now. So the third touch is on the other side. So with these 3 touches, we know exactly where the part is. We go with the raw part at the vise. We take a first picture pretty far out just to have a bigger field of view. Then we take a second picture closer to have a better precision. And then we're gonna know exactly where. Okay, so the second picture didn't work, so I've got a redundancy. So we're gonna take a second picture. Here we go. So we take the finished part with one gripper, place the first raw part in there, and we go place the finished part somewhere else. So that's pretty much the goal. So right now the program stopped, but basically once you've done one contact offset and one visual offset, you would be able to run the program and the robot will still remember where are those locations. So if we go quickly in the program, so I've got the before start, so activating of the gripper open. We've got the find contact offset, so that's a node that we have. So let's say I'm gonna put a new one in there just to show you how it works. So I'm gonna put find contact offset in here. We're gonna teach a sequence. And as you can see, everything is done via the teach pendant. So we choose a feature point. We can do translation or orientation. In this program, I've done both. So let's say we start with a translation. And as you can see, everything in yellow. So this has been populated automatically. So everything that you need to do from now, so you have the transition point and approach point that you have to teach. Then we're gonna have the find surface. So that's a feature with the force torque sensor, the machine tending copilot. So you choose the orientation. there's some advanced parameter that you can modify, so it's pretty easy. So you select the orientation, select the speed, select the force threshold, and then when you touch the edges, you can jump to the next node, which is in this case a retract point. So if I delete that and I go back into the real program, so we've got the fine contact offset. We've got the first one, which is, so this is just a warning saying if you modify this, you can break something, but basically we've got the orientation with 2 touches, as you can see here with the 2 folder, so everything is there. And then we've got a second one, which is the translation. So overall, we've got 3 touches, and it's pretty simple to program. We've got few points, fine surface, and that's pretty much it. From there, we're gonna have the node apply contact offset, which basically we tell the robot, okay, from now on, everything below that node, you can use the new position to make all the movements. So as you can see, like these one were my waypoints and gripper open to go pick the first part into the tray. From there, I've got a grip check. Just it's a function within our gripper to validate that a part has been gripped. So we can do either check if the object is detected. We can also validate the grip dimension with the gripper. For this example, I didn't need it, but it's a good first quality check if you want to measure the part. And from there, so once the grip check is good, so I'm going into at the vice basically, and I'm gonna do a fine visual offset, and that's where I'm gonna select the tag. So you could have as many tags as you want, but that's where you're gonna need to select the right tag. So we take 2 pictures within this one, this node exactly, and then we're gonna apply the visual offset. So same thing here. So we tell the robot, okay, from there, everything below that node, you're gonna use the new position of the vice, of the tag basically. And then we have the waypoints.
This would be a good question to ask, or a good time to ask this question that we got in the chat. Are the tags bolted down or adhesive backed? Just curious how they hold up to coolant in a machine for longevity and quality wise for taking an image.
It's kind of a metal tag, so it's pretty robust. For the machine tending, we will recommend having it outside the machine, so to make sure that you don't have any debris or coolant on it, so it's always clear from anything, so the camera can always locate it. But it's pretty robust. It's a printed metal, and you can only stick it onto the machine.
But it does have an adhesive back to it.
Yep.
Yes. Now you could put that tag inside of the machine on a vise. Actually, in the video we showed earlier in the presentation, they had a kind of an air knife or a blow-off nozzle on the built into the CNC machine tending kit to do a blow-off. So you can use it inside of the machine, but we would encourage you to add that blow-off just to make sure the tag is free and clear of debris. While we're paused for a question, we also got one about what's the best way to automate door opening and closing in coordination with the movements of the robot and grippers. So there are a couple of different ways to do it. You can actually open and close the door with the robot itself, using the gripper to grab the handle or just the side of the gripper to nudge the handle of the door open and closed. But in my experience and in my recommendation, the best thing to do is to add an auto door to your machine, so that the door can automatically be opened and closed via an IO signal. So also speaking of IO signals, we don't have them in this remote demo program because obviously we're not tied into a real CNC machine. But within this program, in order to do something like activate an auto door, you would just add a IO node to be able to set that high or low as Mark's doing on the screen.
Yep.
And then it would be the same thing for a vise if you have a air vise, for example, that can be controlled via IO.
Yeah, so it's pretty simple. So you connect the vise or the actuator for the door on a specific IOs on the robot, and then you can just select the one that is connected, and you can manage the either if you want it low or high. And yeah, that's pretty simple to do with the UR.
Exactly. And my recommendation would be to ask for these products from your machine tool vendor or from Ralph W. Earl as well. All right, thanks, Mark.
Thanks to you. So that's pretty much it for the machine tending demo, but I wanted maybe to open a different program and show you it's an assembly application, I would say, but it can be useful for machine tending as well. So let me just open this one and I'm gonna show it to you. And there's also a different part presentation. So that's one of the reasons I wanted to touch on this one. So basically we've got a small 3D printed cylinder that we have here. So basically we're gonna simulate that parts are placed on the table and in a random way basically, and we're gonna use a 2D camera, so with the cam locate in here. So everything is, so the model is teach via the teach pendant of the UR, so it's really easy. So you can take some pictures and the part will be taught. So you don't have to be an expert in programming or anything. And from there, so again, we use the grip check to validate the grip is good. With this one, as you can see, we measure the part just to make sure that we have the right one in hands. And then we're gonna use the force insertion nodes. So this one can also be used if you want to place something into a vise or make sure that you have the part is well placed. So we've got spiral search, rotation search, and linear search. So these are all monitored with the force. Again, pretty simple. It's really similar to the fine surface. So we can teach a position. We have the orientation as well. Few parameters to monitor the speed, the force, force initiating the spiral move, force initiating the insertion, and stuff like this. Rotation, same thing here. So really similar. We have few parameters. And then at the end, a linear search. So pretty much the same thing as the fine surface. So we push into one direction, and then we have a force threshold. So I'm just gonna play the program. So you're gonna see the camera in action. Go pick the part. And then do the insertion. So camera is taking a picture. We go down for the part, and then we do the insertion in this jig that I've 3D printed as well. So it was just a quick demo to show you that there's a lot we can do with the camera. There's a lot of part presentation that we can do as well. And you can also use the force in different matter as well.
Right, and so these features are very, very useful to make sure that the robot stays running and doesn't run into a fault scenario. If you don't build this kind of flexibility into your program, and let's say your part was misaligned, this spiral insertion is a good one for like a CNC lathe, for example, if we're loading cylindrical parts into a chuck. If that part is misaligned with the chuck and the robot bumps into it without using our force software, it's just going to stop the robot and need an operator to come and intervene to fix the situation. And obviously, that's not the goal of automation. That's not what we want. So with our software, it's a little tough to see just because of how small the movements are, but it's important to know what's happening, that as this robot is trying to put the part into the chuck, the simulated chuck here, it's spinning around and feeling for when that part engages and is able to go past the upper surface and then get fully nested into the chuck.
So I don't know if there's any question, but that's pretty much what I had in mind for the demo today.
All right. Does anybody have any other requests to see while we have the robot and remote demo screen up?
Yeah, I'm not seeing anything additional, Tyler and Mark.
All right, Jason, any input for us before we jump back to the presentation?
Yeah, no, I was just saying how effective the software is for getting that simple solution, figured out. You guys have put together one heck of a software package to be able to, help solve these specific applications in CNC machine tending. So all these things that Mark that Mark and Tyler are reviewing and showing you, these are things that we can do and bring it on site and show you how this can be applied simply to your pieces of automation. So, if there is interest, we'd love to do that type of thing and demo it. right on your floor. So just a little feedback, but it makes it, you guys make it very easy to do.
Perfect. Thank you, Jason. All right, with that in mind, we'll jump back over to our presentation to wrap up this webinar. All right, so I want to open it up right now, and I'll leave contact information both for myself and the Ralph W. Earl team, so you can get in touch with us after this webinar and take the next steps. I would highly encourage you to reach out and contact us, and really let's talk about your project, talk about the parts you're trying to run, the part sizes and everything. And what we can do is match you up with the right kit. It's probably going to be the Robotiq CNC Machine Tending kit, but also help you out with training if needed. Ralph W. Earl is a certified Universal Robots instruction facility, so you can join them for UR training. You can join Robotiq for a remote demo at any time, or use our e-learning platform at any time. And really, I would encourage you to, if you're thinking about taking this jump into cobots and automated machine tending, and you haven't had a chance to do it yet, you're not necessarily behind, but you would be joining thousands of other customers who have automated their CNC machine tending with a cobot, and really, it's something that's revolutionizing the CNC world, because we're able to add more consistency to our cycle time, drive down the cost to produce each part. And if we use something like the drawer-based systems, we can actually have so many parts staged and ready to go that we can run our robot lights out and have ourselves generating revenue while nobody's even in the shop. So all of these things and more are possible by automating your machine tending with a cobot. And please don't hesitate to reach out to myself or Ralph W. Earl to figure out what those next steps are.
Perfect.
With that being said, we can go ahead and wrap up the today's webinar presenting CNC machine tending with Robotiq and Ralph W. Earl. If there are any final questions, please don't hesitate to ask them now. And if you have follow-up questions, don't hesitate to reach out and contact us at any time.
Yeah, I think, Tyler, I think that's it. Appreciate everyone's time, but it looks like that's it for the questions.
All right, perfect.
All right, I'm going to close by thanking everybody for attending. Thank you, Jason, Tyler, and Mark Antoine. And again, if anyone needs anything, please reach out to cobots@rwearl.com or your Ralph W. Earl sales rep. Thank you again.
All right, thank you,
Thank
everyone.
you, everyone.
Have a good day.